Fulla.
Okej.
Det är videobevis. Other things I'm doing is the CIA. I'm in VHDL. I'm trying to understand the data sheet, and this time I'm looking at the serial port, which is connected to the data bus like everything else. So these are modules inside the CIA IC and the Commodore 64, and you have these two timers, and those timers can generate a count. You can make the timer count by using count or the clock, but you can do it the other way. You can make a baud rate for the serial port when it's in output mode, so it's a two-way thing. And the thing is, I have now several VHDL files, as you can see, and I'm done with the interrupt. IO ports is coming along very nicely. Serial port I have just begun. It's not really done at all. So this is all I've done with the serial port. It's not really doing anything yet. So I'm just playing around with a shift register, because the serial port is in fact a synchronous serial port. That means you have a shift register which is controlled by a clock or a count signal. So if you want data in on the Commodore 64, the sender has to drive the count. If you want to push data out of the Commodore, then you have to supply, the Commodore has to supply the count, which is done by the timer. So you set the timer to fire counts for every, you can control it manually. So it also generates baud rate. So what happens when data comes in is that it's shifted 8 times, and then when it's 8 times, the serial data register is loaded and then generates an interrupt. So you see the VHDL code for a shift register. Every time count is rising, whatever was on 0 in that vector over there will go to 1, and then everything that was on 1 will go to 2, and so on. But when you write this one to 1, won't that one be pushed from this one to this, and so on? So DF0 goes to DF7 in one clock cycle? No, not if you're using signals. If you're using variables in here, then that's true. But not when you use signals, because the DFF0 and 1 and 2 as such takes the value that is when count is going up. So you can't move data across like this when you have a signal. It just moves what was in these before count went up. So yeah, so that's a big difference. Okay, I've added signals, and then let's add some internal signals as well. This is the unit under test. That's actually the timer. So let's add the internals also. There you go. So here you can see this is the timer latch that which is loaded into the timer whenever you get an underflow or you get a load signal, which we are going to test here actually. And yeah, several other behaviors. There's also a strange behavior if you read CRA from the CPU. Load is always 0. I can show you that. Oops, it says so in the datasheet. So if I go to timer and then sorry for the shaking here. Okay. Okay, I thought I did a oh, oh, this is a write. Okay, here's the read. Yep, there you see it. 0. So I return 0. These are the latch registers. So you would think, oh, if I read it back, I will get the same value. No, this is the latch. So when you load, the timer will, timer 0 will, you can see it up here, timer will get those two values if you have an underflow or you have a start. And a start, sorry. So, and also here if you have a load, yeah, then you will load these two values. But if you read them back, you don't get those two registers, TA low and TA high. So let's see what you get. So you get actually the timer. That's the thing. So yeah. So let's see if we can run it for like 500 microseconds. That's quite long, but let's say 600. Doesn't matter. 600. Now let's do a full. Just press F. Press F. There you go. So what are we looking at? So in the beginning here I'm setting up the timer. I can show you that in a moment. And we have the clock, and you have a reset. We have a reset to begin with. We have some read pulses in the beginning, just to check what the registers are for simulation's sake. And we have a couple of write pulses, so you can see I'm changing the state of the timer around here. And actually you can see that on the data input, what I'm actually writing. And the RS is the address. So E is the control register, while 5 is the TA, also is the latch. So so how does this timer work? Well, it counts. You can see it's counting. You can zoom in on that. You can also see it has a output which can be used for several things. You can make a frequency. For example, you can use it to drive the baud rate. So by setting the timer latch to a certain value, you can pre-scale the timer and the clock here to this to get the frequency that you want. You have several modes. You can see the mode is changing. So this is underflow flag, which is a signal that I'm using to control this timer out. So every time the timer goes to 0, you get a flag. And over here you can see that the output is changing from pulses to toggle. So for every underflow, you get a toggle. Up, down, that's toggling. And now I fell out of my explanation. Yes, now we can see why is this changing. Yes, because we have a change up here in the out mode. So that's what I'm testing here. We have a run mode, which the Highlander I talked about earlier today, which wasn't working in some emulation program. I think it was FPGA 64. So the run mode is now continuous when it's low. So that means the timer will just load whenever it goes to 0 and then back to FFFF. It won't go into FFFF, it will go to whatever is in this timer latch, which I have written E into the least significant bits. I could have set this one higher, but then the pulses between, or the time between the pulses are so high, so for simulation's sake I haven't done it, but I have tested it. So yeah, so over here I'm changing the run mode such that the timer stops. You can see it stops after a while here, so let's zoom in. So this video is going to be a update video then. Yeah, there you can see the timer values, and you can also notice that when it goes to 0 it wraps around to E. And why does it wrap around to E? Yeah, that's because I have hairs in the beginning. When you have the reset, I do a write, 2 writes here and a here. The first write is in on 4 and 5, which is the address for TA low and TA high. So I write E, value E. So you can see when I do a load, actually I'm not doing load, this is behavior. This is the behavior of the module. So whenever you write to this register, this TA high, then the module will automatically do a load. That's also in the datasheet. So I managed to do that. So the timer loads, but it hasn't started. So over here we do a write to the control register, which you can see changes to E, which is this start bit. So there you can see it starts counting down from E, D, C, B, A, and so on. And it's continuous. So when we continue, you can see, I think I went too far. Yeah, 5, 4, 3, 2, 1, 0, and then you get a underflow over here. And since we have out mode to 0, we will get a pulse out. So, and that's what's changing when you move. Let's see, here are pulses, and then we change the out move. We write something into the E register, which is here, and then you get out mode high, and then you can see we are getting toggles on the output. So that's working, and in the end here we will see we are writing something more into this control register. Just shift my hand here. You can see the CRA is now changing from, it's still in start, it's running. We can see PBA has changed, but this has nothing to do with this timer really. It has something to do with the port, such that you can get the timer out on the port. But since I'm not simulating the port, the PB GPIO, it's not doing anything. We're changing the out mode, and we are changing the run mode. So now we are going back to one shot. That means when the timer goes down to 0, it should stop. So you should see the start bit go to 0 then. So let's move on. You see the timer 7, 6, 5, 4, 3, 2, 1, 0, and it stops. And you can see the start beat. Sorry. Also stops here. Stops at this edge. So it's working. I don't think I'm doing anything more after that. And another thing I've tested is this timer clock. You can take clock from either phi 2 or count. There. I see I have a slower count, but I haven't. Maybe I'm doing that in the beginning. Let's see. No. I have tested it, so it works. That just means that the clock is running slower. So, and now I have to figure out what I'm going to do with this timer out and this count, because I think maybe this module is supposed to drive the count when it's used as a baud rate. So yeah, maybe it's that in mode or out mode, maybe. Oh, serial port mode. Yes, that's it. I haven't done that yet.